covalent bonds. Does anybody from their chemistry class, because some of you had it, remember covalent bonds? Because we're taking a covalent bond, which is another major type of bond, and I kind of want to compare it to ionics because there's differences. What do you know about covalence?
They share valence structure.
A covalent bond is defined as a sharing of valence electrons. And I probably spelled valence wrong. So what does that mean? What does sharing of the valence electrons actually mean, do you think? Yeah.
Where if one atom has enough, or has 8 valence electrons, another one can come in and come together. And
right.
Connect with it.
They come together. They overlap their valence electron orbitals, and then they both get the benefits of having those electrons around the outside. So here's my example that I use all the time. I have hydrogen. I'm drawing one in black marker and one in blue marker. Hydrogen is an easy one to talk about because it's the best one to talk about. Why is it easy to talk about? How many valence electrons does hydrogen have? It's got 1. So this blue hydrogen has 1 blue dot. This black hydrogen has 1 black dot. Are either of those two happy? No, but they're a special case. How many make them happy? 2. Hydrogen's special. Helium is special. They only need 2 because how many electrons go in the first energy level? 2 trailer park girls go around the outside. It only needs 2 to make it happy. So, I always ask this. What kind of charge does the nucleus of every atom have? It's going to have a positive charge. Why does the nucleus have a positive charge?
That's where the protons are stored.
Because that's where the protons are stored. And what do we know happens between protons and electrons? What's going to happen? They balance each other out, but what happens with positives and negatives?
Subtract.
They like each other. Nick, Scotty, come here for a second. So what's going to happen? I'll wait for up. What's going to happen with this nucleus if it gets close to that hydrogen? That nucleus is going to want to do what? I say it lassos it. Right? It's going to lasso that electron. Well, what's going to happen with the blue hydrogen? As it gets closer to the black hydrogen.
And with the black dot.
The protons and the positive charge is going to lasso the black electron. So come here, guys. On the middle. I have one hand shaking. My other hand is shaking. Right. So what happens if they pull on each other at the same time? No, not me. Which is fine. But what's going to happen if they pull on each other? What's going to happen to them? They're going to come together. Oh my God, look at it, so cute. I chose 2 people to be able to. I chose 2 people to be able to handle it. What happens with those 2 hydrogens as they lasso the electrons? Because this one doesn't want to quite give it away. So as you're pulling that electron, that hydrogen's like, wait. So as this one's pulling this hydrogen, what's happening to that hydrogen? It's slowly moving this direction. What's happening on the other side?
Going the same way?
The exact same thing. The exact same thing. I don't like it. So eventually what's going to happen is these 2 guys are going to get so close that their outer shells overlap. So I'm left with a hydrogen and another hydrogen right there. Now, remember, how many does hydrogen need to be happy?
Those.
2. So if I cover up that hydrogen and it's kind of hard to see for the people on the other side. How many dots are right next to that hydrogen? If I cover up the blue one, how many dots are there? There's 2 because they overlap. If I cover up the the black hydrogen, how many electrons are around that hydrogen? 2. So are they happy and stable now?
Yes.
Yes, because that lasso effect. That's what I use. I don't know if any other teacher uses that, but that lassoing effect of pulling them closer together makes them bond. Now, this is a strong bond. It is hard to rip this crap apart. Because of the overlapping of the electrons, they don't want to get pulled away because they want to be stable. Also, another way to define a covalent bond, it's not just the sharing of electrons, right? Because I used, in an ionic bond, I compared it as a metal plus a non-metal. Covalent bonds are bonds between 2 non-metals. Right? What's the most common covalent bond, do you think, between 2 non-metals that you guys deal with every day? And according to a specific movie, if you go without it for 7 days, you die? Water, right? Isn't that the ring?
H2O.
Isn't the ring, if you go without water for 7 days, you die? Was it food or was it the ring?
No, the ring is they watch the show. They watch
Yes,
the
but
TV.
then they go in the well, and if they, because of them being in the well for 7 days, after 7 days of watching the show, they die because it was supposed to be connected to.
I don't know.
You guys need to go back and watch The Ring. Bottom line, that's all that comes down to. So let's talk water for a second. I probably shouldn't have erased that, but let's talk water. Oh, let's talk about water, bro. Let's talk about water. What's water made out of? We know its chemical formula already. H2O. Oxygen has how many valence electrons? It's got 6. So how many how many hydrogens would it need to make itself happy? You need 2. So it has 1 hydrogen that's over here. It floats itself in. They share. So now I have a hydrogen chilling right there. I have a second hydrogen that comes in, floats itself in right there, and now I've made a molecule of water. Because oxygen has 6, it needs 2. If I cover up the 2 hydrogens, is oxygen now happy? Yes, oxygen is happy. If I cover up the oxygens, are both of the hydrogens happy? Because hydrogen has 2 now, oxygen has 8. Yes?
How many H2O
There are 6.02 times 10 to the 23rd water molecules in 22.4 liters of liquid. Anybody in chemistry remember those numbers?
No.
At standard temperature and pressure. A mole. You didn't talk about moles?
Yeah, we did.
Yeah, you did. Guarantee you talked about moles. So, here's another one I'm going to put up on the board. There are several bonds that you guys have heard of. I want you to try and figure out how to make nitrogen bond to oxygen. You'll know that one in a second. I want you to do carbon bonding to oxygen. And then, what's another one that I know that we can get to share? What's another covalent, easy covalent bond?
6.
Oh, well, how about chlorine to chlorine?